Assalamualaikum and good day to everyone. So today we will proceed to new chapter, which is if you look at your CI, okay, we are supposed to enter a new chapter, which is electrostatic field in a medium. All right. So first of all, I would like to give an introduction. What will you learn for electrostatic field in a medium? All right. So let's look electrostatic field. Okay, we have learned before about electrostatic field, where we know that for electrostatic field, it is a very special field where we will say that the field contain only electric field and no magnetic field. All right. And another condition that we have stated before, that the electrostatic field is independent of time. So we will not consider time in that particular situation. All right. And let's do a fast recap from what we have learned before. As I said, that EMT is always continuous from one chapter to another. All right. So from previously, we have learned that the source of source to generate that electrostatic field is always a stationary charge. Okay, we assume that it is always a stationary charge, and I represent it as rho v, where it is a general representation of volume charge density. Okay, and from this stationary charge, we can find E, which is electrofield intensity. We can find electrofield density. We can find and measure the potential, and also from what we have learned previously, we can also define the work in a system. All right. However, all this particular electrofield intensity, density, potential, and work, it is happen in a medium. Okay, in one medium, where we have agreed that the medium that we have discussed before is a free space medium. Okay, and therefore we are dealing with we are dealing with epsilon naught, right? However, in real world, okay, the medium is not always free space, right? The medium can be defined as conductor, semiconductor, and dielectric. This is what happened in real world. Okay, this is what happened in real world. So therefore, in this chapter, we will look how if electrostatic field, how if it is happen in different medium. All right. However, in this course, in this EMT course, we will not discuss about semiconductor, since that we assume that semiconductor will be learned and discussed deeply in other courses, for example, electronic course. All right. So in this EMT course, we will focus only on conductor and also dielectric. All right. Okay, now let's look here, electrostatic field in a different medium. Okay, so first of all, let's say that we have a medium here. So in order to define this electrostatic field in a medium, okay, we should know there are three components. Okay, there are three components that we should know. All right, so the first thing that we have to know, that the medium that we will deal with. What is the medium? Okay, what is the medium that we will deal with? Either it is conductor, or either it is a dielectric. Okay, and other than that, okay, after we know or we define what is the medium, we should also know the other components, which is the applied field. Okay, the applied field to the medium. Okay, either it is an electrostatic field or magnetostatic field. However, in this chapter, since that it is discussing about electrostatic field, so we assume that all the applied field is electrostatic field, right? But in real world, it can happen in electrostatic field or magnetostatic field, all right? But in this course, we will deal only for electrostatic field, all right? And then, okay, after we define, this is number two, yeah? The number two components that we need to know is what kind of field that is applied to that specific medium. The last thing that we should know is the charged particles, okay, the charged particles inside the medium. All right, and usually, generally, in this chapter, the charged particles, yeah, is defined as, or it's represented as rho v, which is the volume charge density, where this charge is filled inside this specific medium, and therefore it is represented as rho v. Okay, so we want to measure, or we want to observe how the charge, yeah, this charged particle respond to this applied field. How this charged particle respond to this applied field. All right. If this charge is moving, okay, let's say that now the field that applied in this medium is this direction. So by right, by nature, we know that the field will, that this charge, yeah, these particles will move as the direction with the field, right? So if this charged particles moving, okay, we will say that the medium is in conductor state. However, if this charge is not moving, this charge is static movement, okay, it's not moving at all. So we can say, or we can define that the medium is a dielectric medium. All right. So if so in equations, if they didn't mention specifically what is the medium of this structure, you can see, or you can guess, or you can assume the medium by looking at the movement of the charged particles. Yeah, if the charged particles is moving, so it means that it is a conductor medium, and if the charge is static, it is a dielectric medium. All right, I hope it's very clear up until here. Okay, so now let's look what are the topics that we will learn in this electrostatic field in the medium, as this is an introduction to you. Yeah, so in this chapter, we will discuss about current. Okay, we will learn about conductor, and we will learn about dielectric, and lastly, we will learn about how is the applications of all those things. Yeah, okay, by right, we will learn the application is much more important. Yeah. Okay, so in current, we will learn about the three models of current. Okay, there are three models or three equations of currents that we will learn in this chapter. Okay, so current in this chapter, yeah, is defined as moving charge. Okay, current is defined as moving charge. Okay, and current in this case, yeah, in this chapter is no longer the charge, yeah, is no longer a stationary charge. Yeah, so the charge is a moving charge, and current, okay, is a moving okay, when the charge is moving, so we assume it as a current. All right, and then we also will learn about conductor. Okay, so in this conductor, we will learn about conductivity. Okay, where this is the symbol of conductivity. Where what is the meaning of conductivity? Conductivity is to define, yeah, to define either that particular structure or material is a good conductor or a bad conductor. Okay, so if this value is high, so it means that that particular material is a very good conductance, and if this conductivity is low, the value is low, so it means that that particular material has a very what is not a good conductor. All right, so conductivity is very important for you to define the characteristic or the types of that materials. All right, and then we also will learn about the conductor or free space boundary conditions. Okay, we will learn about the conductor of free space boundary condition, where we will observe what will happen. Okay, what happened to electric field when it propagate from conductor medium into free space medium. Okay, we will see what will happen to that electric field when it's propagate from a conductor medium to free space medium, or vice versa, from free space medium to conductor medium. What will happen to that electric field? We will learn in this conductor. All right. Okay, under dielectric, we will learn about dielectric under static conditions, and we will also learn about dielectric boundary conditions. What other conditions will be? All right, and last but not least, we will learn about the application on all of this current conductor and dielectric in a form of capacitance. Yeah, we will learn about capacitance, okay, which is the applications of all the topics that we have learned in this chapter earlier. Okay, and we will look about the situation consists of various medium. Let's say that the capacitance consists of dielectric and conductor. What will happen? Okay, we will learn about the situations consists of various medium in a capacitor. Right, so these are the topics, or these are the things that we will cover in this chapter. So this is just an introduction video. So I hope by this, you have a big picture what we will learn about the electrostatic field in a medium. All right, so that's all. Thank you very much.